So for this screencast, I'll be talking about my own problem that I've drafted. So it's basically a heat exchanger design problem. So we have a stream of ethanol and water, that's 60% ethanol, 40% water, that's going through a heat exchanger on its way to a distillation column to give it more energy in order to vaporize. So we have this stream coming in, and we know its flow rate. We're determining the type of heat exchanger we want to use out of the many ones. Again, this is something I can't really solve yet because we haven't talked about this, but I'm assuming that by the end of the course I'll know more about how to design heat exchangers, as that's one of the learning outcomes. We know some of the properties of the steam stream, which is the heating element of the heat exchanger. It's at 140 degrees Celsius, 1 atmosphere. And we're trying to find the flow rate of this stream that's required to increase the temperature of the ethanol water stream by 10 degrees Celsius. And then we're also wanting to construct a plausible schematic for this heat exchanger, including maybe some dimensions. Again, haven't gotten to this point in the class yet, but this is something that I'm interested in. And then we can I also wanted to demonstrate like a specific part of the heat exchanger where you have the convection on one side, you have conduction through the heat exchanger, and then you have another convection layer. So the learning outcomes that this tackles is modeling and designing heat unit operations, specifically the heat exchanger, internal force convection, I believe, as we're going to be, forcing these two fluids through a heat exchanger, and that will increase their rate of convection. And then also some steady state heat transfer, as this would be a steady state process, and obviously there's heat being transferred.